Okay, for those of you who are at home, we did a bell work problem. This is it. Carly showed us how to do it. Okay, there's a question on number 35. Okay. Looking at this, what property, and by the way, let's just review the properties really quickly. Last time we learned the three properties. The product property is just if you have log base b of m times n, two numbers being multiplied together. If you have two numbers being multiplied together, log base b of m times n, that's equal to log base b of the first one plus log base b of the second one. That's like the one Carly just did right there on the bell work problem, okay? And I wrote an example of like log base 3 of 4 times x. You can separate that into log base 3 of 4 plus log base 3 of x to two logarithms, or vice versa, okay? Now, the quotient property, if you're dividing m divided by n, you can separate it into log base b of m subtract log base b of n. Remember, these are all based on the properties of exponents that we learned before. And then the power property, log base b of m to the p power is equal to p times log base b of m. You can move the power down in front. Do you see that? So we're going to use these three properties. Carly, did you get those properties down? Is that what you're doing right now? Okay. Since you weren't here, was anybody else not here last time? Okay. So those three properties is what we used to do this assignment. So if we're looking at this problem right here, which one of these three properties is the quotient property? Yeah. So I can combine, since these are both base 2, I can take log base 2 of the first one, which is 12b minus 21, divided by the second one, b squared minus 3. And that's going to be equal to 2. Now, from there, what can I do? Well, most of the ones that we've done so far, you guys had another logarithm of base 2 on the other side, but go back to the very first assignment, 9-2 that we did, and we could change this to what form? Yeah, we can change it to exponential form. So if I change it to exponential form, what would it say? Yeah, you remember the base is 2. That's what's going to be squared. So 2 squared. The b squared minus 3 is the denominator. I probably should put parentheses around this. Okay. So yeah, you have this rational equation. Okay. How do you solve a rational equation? What do you do if I need to get b squared minus 3 out of the denominator right here? Yeah. First I have to what? Okay. Well, I couldn't factor a b out of either one of them, but I could factor a 3 out of the top. I could do that. Yeah. I'm going to times both sides by b squared minus 3. If I do that, they cancel out over here, right? You see that? And then over here, I have 2 squared is 4. So I have 4, if I distribute that, b squared minus 12 equals 12b minus 21. Now I have what kind of equation did you say, JD?
Quadratic.
Now I have a quadratic. Yeah, so I got to get it equal to 0. So I have the 4b squared here. I minus 12b from both sides. And I add 21 to this side, and that would give me 9. Okay, and so I have this quadratic equation right here. We could use the quadratic formula on it. We could factor it if it factors. Does anybody see if it factors? Looks like to me it factors.
Does?
Uh-huh. You got these 4s right here, 2 times 2, right? 3 times 3 right here. If you notice, 2 times 3 is 6. Another 2 times 3 is 6, and you get 12b, but there's a minus sign, so what are my two factors going to be? Or 2b, yeah. 2b minus 3, and, whoops, 2b minus 3 again, right? They're the same factor, so I just solve one of them. So what's your answer going to be? 3/2. Now we can check to see if that's going to work. Back in here. 3/2. We go back to the original problem. And I substitute 12 times 3/2 is what? Is 18, right? 18 minus 21. Oh, wait. 18, look at you guys. If I go 12 times 3/2, I go 12 times 3/2, 2 will go into 12 6 times, and 6 times 3 is 18. What's 18 minus 21? It's -3. Can I have a negative number right there? Can I have this number that comes after the logarithm, can it be negative? By definition of logarithms, it cannot. It has to be a positive number. Okay? And so 3/2 squared is 9/4, so 9/4 also would give us a negative number. So I would say this is an extraneous solution. What number is this? 35. I would say that there is no solution. What do you guys think? They show 3/2 as a solution, but I think it's extraneous. I think it's extraneous because if you put it in there, you're going to get a negative number. I think whoever made this key didn't check to see if it was extraneous. Which problem? Number what? 36? They show a solution for this one, and that solution would work looking at it. Okay. 36 is almost exactly like this, and it's probably a little bit easier than this one. What? Does it? Well, let's try it. Okay. What's the equation? Log
base 2 to y plus 2.
Of y plus 2?
Minus log base 2 of y minus 2 equals 1.
Well, what's the property we're going to use right here, you guys?
Same quotient.
Okay, quotient. So
Log base 2 to y.
Log base 2 of the y plus 2 over y minus 2 equals 1, right? Okay. We can't cancel out y's. Okay, well, before we do that, we got to change it to
So it's 2 equals y.
2 to the 1, which is 2, equals y plus 2 over y minus 2. I can't cancel out y's here because they're not factors.
So times y minus 2.
Times y minus 2 to both sides.
4.
Those cancel out. 2y minus 4 if I distribute.
So y.
Solve that equation. You got your answer. If you change from exponential form, 2 to the 1 power equals all of that. Remember the exponential form? We learned the first lesson on logarithms. We changed to exponential form. 2 is the base of the logarithm, so it's the base of the exponent. 1 is the exponent. And that's equal to what was left inside here, y plus 2 over y minus 2. Okay? So we just changed to logarithmic form. Okay? All right, any other questions on that? And then you just need to solve that one. Okay, so number 38, you have to use a combination of of these properties, right? So I would just start left to right, okay? I have log base 5 of 64 minus log base 5 of 8/3. How could I combine those into a single logarithm? Say that again. So log base 5 of 64 divided by 8/3 plus log base 5 of 2 equals log base 5 of 4p. Now, could I simplify 64 divided by 8/3? 64 divided by 8/3. How do I simplify that? Say that again. 6? It's not 6. Huh? Yeah, because, well, what do you do? 64 times what? 3/8, right? 8, we're going to 64 8 times. 8 times 3 is 24. So 64 divided by 8/3 is 24. So now I have log base 5 of 24 plus log base 5 of 2 equals log base 5 of 4p. So what do I do next? Okay, so combine these two logarithms to be what? Log base 5. What was that? Well, once we get them to be single logarithms on both sides. So log base 5 of what? Okay. And log base 5 of 4p. Now I can, like you said, Cole, I can drop the logs, right? Because if these two are equal, they have a single log on each side, they're both log base 5. That means that the 48 has to be equal to the 4p. So we can just write 48 equals 4p. So what's p? Okay, 12. And that will work. Okay? All right, we're going to move on. You guys, that's enough of those. We're going to move on. Okay, today we have two objectives. The first one, I wrote up there on the whiteboard, solve exponential equations using logarithms. Okay, I wrote it over here as well. Today you will learn to solve logarithmic equations using common logarithms. And you will also learn to change the change of base formula so that you can find the value of any logarithmic expression. You guys all said, how do you put this into your calculator? You guys keep wanting me to show you. I told you we're getting to it. You didn't need it before now because I wanted you to think about what a logarithm was and guess and check the answer. But now that we've done a little bit of that, I'm going to show you the change of base formula that will allow you to put it into your calculator and evaluate those expressions. So to begin with, I want to talk about what is a common logarithm. Write down that question. What is a common logarithm? And the answer is written right there. A logarithm with base 10. And there's an example right down here. Log base 10 of x equals 2. That's a common logarithm because the base is 10. They call it the common logarithm because it's the most commonly used base.
What are they logarithms for?
To solve problems where your variable is in the exponent. And so you have to change that from exponential form to logarithmic form in order to solve it. Okay? So, you guys, common logarithm just has a base of 10. Any questions there? So, if a logarithm does not have a base, in other words, you don't see a base. Not that it doesn't have one, that you don't see the base, like log of 2100. You'll notice right here, there is no base. You see that? If you don't have a base, then we can assume the base is 10. So you can make that assumption. Got it? It is a common logarithm. It's common enough, and they just don't even write it in there. Now, I want you to notice on your calculator.
They use the common law.
On your yeah, exactly. JD just said that. If you guys notice on your calculator, as mine comes up here, you have a button that says log on it. That is the common logarithm. That's a base 10 logarithm. I would probably write a little note to yourself. This is the base 10 logarithm. Okay? So, just clear this out. But yeah, right down here you have the log button. So that problem, let me just shorten this screen up right here so we can see both of these. Ask me to find the log of 3. Well, all I have to do is go log 3. Enter. 0.477. Remember, this is really log base 10 of 3. And if you want to put a y equals y over there, this is asking 10 to what power is 3, right? Well, obviously, since 3 is smaller than 10, y had to be a decimal. You see that? And so, anyway, your calculator will evaluate those. Does that make sense? So, your calculator, the log button on your calculator is a base 10. We done writing that? Almost. Okay, right here. We're going to solve an equation. Make this bigger for a second. We're going to solve the equation 3 to the x equals 11 using a common logarithm. Now, we all know the properties of equality. Whatever you do to one side of the equation, you have to do to the other side. So one of the techniques in solving equations like this is to take a logarithm of both sides. So I'm going to go log. I'm going to use a common logarithm, log base 10. So I'm not going to write 10 every time there because we're just using the common logarithm. Log of 3 to the x equals log of 11. So what I did right there is just took the log base 10 of both sides. Okay, whatever you do to one side, you have to do to the other. Now, notice that I have an x. The x is my variable, right? I mean, my x is in the exponent. Do we know something that will allow me to get it out of the exponent? Yeah, the power property we just learned, right? How could I rewrite this then? Yeah, x log of 3 equals log of 11. Using that property that we learned last time, the power property, I can put the x down in front, right? So going back to Trayson's question, what do they use logarithms for? Well, it's used to solve problems where the variable is in the exponent, okay? So now, what can I do to both sides of this equation to get x by itself? Well, think of what you normally do in an equation like this. This is the same. 3 times log of 3. What? Yeah, divide by log of 3. If I divide both sides by log of 3, they cancel out over here, and so my answer is x equals log of 11 over log of 3. Can we put that into our calculator? Okay, so we can come over here and we go log 11. So log of 11. Make sure you put the close parentheses, you guys, after the 11. Divided by log 3. Hit enter, and our answer is about 2.183 if we round it to 3 decimal places. Go ahead and round it to 3 decimal places again today, all your answers. 2.183. Okay, so that's how you solve one of those. Okay, that wasn't too bad, was it? Painless? Okay. I want you to do these two with your shoulder partner. You work with those guys right there. You two. You two. Okay, here we go. I want you to do these two problems right here. I want you to trade. Person A does number 1 while person B watches. And make sure they do it right. And then person B does number 2 while person A watches. Okay, go. Okay. Hey, what'd you guys get for this answer right here? 1 point, what? 953. What'd you get for this one down here? Does everybody agree with those? Someone, I overheard Trevor talking. And he just found out that if you take this number right here and go log of that number divided by log of that number, you get your answer, right? I mean, he just knows that's the pattern, so he just started putting that in there, okay? All right, now, second thing, change of base formula. This will allow you guys to evaluate expressions where you don't have the common logarithm, where you don't have a base of 10, because your calculator has a base 10 on it, right? And not all our logarithms have base 10. So sometimes we have base 2, sometimes we have base 5, sometimes we have base 20. So they didn't want to put a log base 2 on every calculator, and a log base 3 on every calculator, and a log base 4 on every calculator, and all those bases on there. So they made the change of base formula, and we just put log base 10 on there. Although some of the newer calculators, like JD's, and some of these yellow calculators, about 4 of them in here, that will actually allow you to put a base in and then the other thing, and it will automatically put it through the change of base formula. But then that's kind of crippling you, because you need to know the change of base formula so you can solve equations. Okay? So I'm going to show you how to use the change of base formula to find log base 5 of 12. As soon as you guys get through writing this down. Does it look bigger? This says log base B of n.
B is 10, right?
And log base B of A.
B is 10.
So B is what? Yep, B is 10. B is going to be 10. You can change it to any base you want, but we're going to change it to base 10 because that's what our calculator has on it. Okay? And then we can put it in the calculator. So we're using the change of base formula to change everything to base 10. So you'll notice all this is saying over here is whatever number is right here, you're going to take log base 10 of that number, divided by log base 10 of the base. Okay? So if I'm going to rewrite this one, what am I going to write? Log base 10 of 12, and I'm not going to write the 10, over log base 10 of 5, which is just log of 5. Put that in your calculator and you have your answer.
What the 5 is awesome.
Huh? 1 point what? 1.544 approximately, right? I should put. No, 1.544 is the answer. That's the answer to log base 5 of 12. We just used the change of base formula to evaluate it. The new base we used was base 10, right? Log base 10 of 12 over log base 10 of 5. So it's all it is log base 10 of this number over log base 10 of 5. Okay? All right. Everybody, evaluate this one in your calculator.
Is that 25?
Log base 4 of 25. Okay, what'd you guys get for the answer? 2 point what? Everybody agree with that? Okay, so now you know how to use the change of base formula. Let me show you 2 more examples, and then I'll let you have the assignment right here. Let's do this one right here. I want person A to do this one while person B watches. Okay? 11 to the x squared power equals 25.4. 11 to the x squared power equals 25.4. You're going to solve this one just like you did those others a little bit ago. Okay, looks like most of you had it. Some of you are stuck. Look, we do the same thing, you guys. We take the log of both sides. Remember, that's base 10 because that's what's in our calculator, right? We use the property, the power property, to move the x squared down in front. Right? Then we divide both sides by log 11. Log 11's cancel out, and I get x squared equals log of 25.4 over log 11, right? Then I evaluate log of 25.4 over log 11. Someone tell me what that number came out to be. What? 1.349. And then I got to get x by itself, and it's still being squared, so what do I do to both sides? I square root both sides, right? And I should have got like 1.161, right? Approximately?
Yeah.
Does that make sense? Okay, I want to do one more. Okay, I want to do this one. 7 to the t minus 2 power equals 5 to the t power. Let's talk about this one. Let's see how far you guys can get on it. Let's see if you can do it. By the way, there is more than one way to solve this. JD had one way, someone else had a different way. Let me just show you. This is the method I've been showing you. Take the log of both sides, the log of base 10, okay? Okay, so I'm going to take the log of both sides. That tells me I got to put the t minus 2 down in front using the power property. And put the t down in front over here. How many of you did it the way I'm doing it right now? How many of you did it a different way? JD did. Okay. Then, what I'd want to do right here is I would want to distribute the log. Actually, probably be faster if I divided both sides by log of 7. Can I cancel out the 2's? No, because I'd have to distribute first before I could do that. Okay, so log of 7's cancel out here, so I have t minus 2 equals t times log of 5 over log of 7. Someone evaluate. What's log of 5 divided by log of 7? Huh? 0.825? Point what?
827.
0.827. So I get 0.827 t. Some of you guys are saying the t's cancel out, but they don't. Okay? Okay? Then I would want to gather the t's to the same side. And I like my t. Well, it doesn't really matter. I'm going to minus t from both sides of this. Whoops. So minus t. Remember, that's minus 1t, right? So I'm going to get negative 2 equals negative, or 0.827t minus 1t, which is going to be, what's 0.827 minus 1? Negative what? 173. Right? T. And then I would divide by negative 0.173. Those cancel out. And I would get t equals negative 2 divided by negative 0.173. I just subtracted 0.827 minus 1. Remember, there's a 1 right there.
I just didn't divide it. I didn't know what else to do. is 11.5.
Combine those like terms. Those are like terms because they both have t to the 1 power. So what does that come out to be?
67.
Say that again.
11.567.
11.56.
One.
What's 1? 561? Okay. Well, it probably depends on how far you took the decimal out on the previous problems. Some of them, it would be more accurate if you took the decimal out further. So we ended up, the answer in the book is 11.5665. So, yeah. Yeah, so JD had it more accurate, okay? So this is the way I did it. JD did a little bit different. Anybody else do it different? A lot of you guys did it the same way I did it. Did anybody come up with the answer before I did, besides JD?
I just had to divide it. I didn't
Yeah, some of you guys are getting down. You guys are getting caught up in the algebra part. That's a little bit harder for you. All right. Here's your assignment for next time. Remember, 9-3 will be due next time. We'll review this one. I'm going to turn this off in a second, so hurry and write it down.